Before you execute any complex operations, there's one critical check you should always make. How do you verify your MCP server is actually reachable and responsive? We'll use FastMCP's built-in ping method to confirm server connectivity with a single async call, ensuring your client can communicate before attempting any real work. This simple pattern prevents wasted time debugging silent connection failures.
Async with client. Await client ping. Print, server is reachable.
This demonstrates the context manager pattern for resource lifecycle control in asynchronous systems. The pattern ensures proper connection handling by binding setup and teardown operations to a defined scope, preventing resource leaks or connection state issues. What makes this distinctive is its integration with Python's Async ecosystem, providing deterministic cleanup even in complex asynchronous workflows. The approach works by encapsulating connections state within the context manager's enter and exit methods. When you enter the async with block, the client automatically establishes the connection and performs initialization handshakes, while the exit handler guarantees proper cleanup regardless of operation success or failure. This separation of concerns lets you focus on business logic, while the framework manages transport details, connection pooling, and error recovery. This pattern matters because it solves the common problem of connection management in distributed systems. Without it, you'd need manual try-finally blocks for every operation, risking leaks or inconsistent states. The context manager approach is particularly valuable in testing scenarios, production services with high reliability requirements, or any situation where you need predictable connection behavior across multiple operations. The trade-off is slightly more boilerplate for the guaranteed safety it provides. Let's break it down line by line.
Async with client.
Context manager pattern for async operations ensures the client connection is properly initialized and cleaned up after use, preventing resource leaks. The async with syntax handles both setup and teardown automatically.
Await client ping.
This sends a lightweight ping to verify the server connection before proceeding. Critical for async operations, it fails fast if the server is unreachable, preventing wasted work on a dead connection.
Print, server is reachable.
This confirms server connectivity after the successful ping. Simple console feedback that verifies the client-server connection works before proceeding with operations. Server connectivity pattern. The ping operation in FastMCP establishes the most fundamental contract between client and server, a silent handshake that confirms reachability without exchanging meaningful data. A successful ping doesn't guarantee all server capabilities are available, only that the transport layer is functional. Always verify capabilities through initialize result after ping succeeds.
The connection that speaks nothing answers everything.